Alright, so we're looking at a very basic electric circuit. As you can see, there's some parallel sections, resistors. We are making a certain assumption that the resistance in the battery and the connecting wires are negligible. So this is the only difference between grade 12 electric circuits and the rest of the grades electric circuits. So all the way down through NS, you will be working with circuits that look like this. Now, this is just a recap, but remember, when you're doing your identification of your variables, you cannot just take a resistance value from one section, a potential difference from another section, and a current from somewhere else. Each resistor will have its own set of variables, so that when you do make an identification, you need to make sure you're using the variables for the same resistor. So there will be a resistance, a potential difference, and a current value for each resistor. And I'm just going to find every resistor I have, and above each one, it looks like I'm writing someone's name, I'm going to write resistance, potential difference, and current. Now, obviously, for this resistor, I don't know the resistance, don't know the potential difference, don't know the current. For this resistor, I do know the resistance, it's 3 ohms. I don't know the potential difference, I don't know the current. Here, I do know the resistance, it's 1 ohm. I don't know the potential difference, I don't know the current, but when we're answering our question for when the switch is open, that is irrelevant because this resistor is actually not going to take part in our calculations or in part of our circuit. And then this resistor here, I know the resistance is 2 ohms, the potential difference is 4 volts, and the current, I don't know what it is. So this is your basic identification before you even go to answering a question. Now, they ask us to calculate the reading on ammeter number 2. So if I come to ammeter number 2, here's ammeter 2 right here. I look for the resistor that is right next to ammeter number 2, if I can find resistor, if I'm going to use Ohm's law. And there we can see, here is my resistor, right in series with my ammeter. Remember that when it comes to ammeters, your resistor is in series. When it comes to voltmeters, your resistors are in parallel. So I can identify these particular variables right here. So I know I'm dealing with R, that is 2 ohms. I'm dealing with my potential difference, which is 4 volts, and I'm dealing with my current, which I'm trying to find. Step 1. Step 2, pick your formula. So Ohm's law, R is equal to V over I. Step 3, substitute. Please do not rearrange this formula because this is how it appears in your data sheet. So when you do your step 3, your substitution, even if you have a weakness when it comes to changing the subject of the formula, please substitute in the formula as given. Do not change the formula, because if you have a weakness for making something the subject of the formula with values, I promise you're going to have a weakness with it as a variable. So stick that in the calculator and I end up with 2 ampere. Great. Now they ask me to calculate the reading on voltmeter number 2. Where's voltmeter number 2? Here is voltmeter number 2. What you need to pay careful attention to is every value that you calculate, how does that affect the rest of your circuit? So now that I've calculated current in my ammeter number 2, I know that this value here is going to be 2 ampere. How does that affect my circuit when switch S is open? When switch S is open, what happens is that this entire circuit is actually a series circuit. So if I can just prove it to you, a series circuit means there's no break in the connection. So there we go, through the first resistor, through the second resistor. Switch S is open, so obviously I cannot go in that branch. So there we go, through the third resistor, and I come back up here, and then I continue, and there we go. I end up right at my beginning of my battery. So what you can see is now when switch S is open, this is actually an open circuit, an open circuit. So an open circuit, not open circuit, a series circuit. When switch S is open, our circuit is in series. So we follow the rules for series. And what do we know about current in series? Current in series is constant. So that means each one of my resistors has exactly the same current. This resistor here is now going to have a current of 2 ampere, and because this resistor is also in series, it's going to have a resistance of it's going to have a current of 2 ampere. So by answering this one question, I have actually filled in more information along the line. So when I'm calculating my reading on V2, which is voltmeter number 2, I'm going to look at the resistor that it is in parallel with, and that is this resistor here. So step 1, identify my variables. My resistor is 3 ohms. My potential difference is what I'm trying to calculate. My current is 2 ampere. That value is coming from here. Alright, so hopefully you have positive marking with your educator. If you don't have positive marking, then you're up the creek without a paddle. Ohm's law, R is equal to V over I. Substitute exactly as you see it. So 3 is equal to V over 2. And then that means your potential difference is 6 volts. Please don't just write 6. You need to put the SI units. In some cases, without the SI units, the value itself is null and void. Next question. What is the reading on voltmeter number 1? And there is some information before that where they say that the EMF is 12 volts. So what is the reading on voltmeter number 1? It has to be 12 volts. Remember, we're making the assumption that the resistance in the battery is negligible. And that's only because we make that assumption that we can say that the reading on the voltmeter across the battery is equal to the EMF. Lastly, they ask us to calculate the resistance of resistor R. Now, in order for us to calculate the resistance of resistor R, what do I need? I either need previous knowledge of my total resistance, in which case I can work backwards using resistance, or I need to find my potential difference. Okay, so there are two routes in order for me to go to step 2, which is using the formula to get to my answer. I do know my value for current, which is 2 ampere, but that is all I know. Okay, so this is the information that I have. What else do I know? I know the reading on V1 is going to be 12 volts. What else do I know? I know the reading on V2, which I previously calculated, is equal to 6 volts. And I know that the reading on this particular resistor here is 4 volts. So I can in fact calculate with my total potential difference. I can calculate from my total potential difference that missing potential difference for my resistor. So not V1. Let's just change it out there. Okay, so V1 is equal to V2 plus the potential difference over my resistor, which is VR. I'm just going to use a subscript R, plus my 4 volts. Okay, now here I've got 12, here I've got 6, here I'm trying to find this value, and I've got 4. So what does that lead me to? It leads me to my potential difference across that resistor that I do not know is equal to 2 volts. Alright, so it's 12 minus 6 is 6 minus 4 is 2. So now all of a sudden I have this value, which is the value that I require over here. I've got V, I've got I can calculate my resistance. So my resistance is equal to potential difference over current, and my potential difference is 2, my current is 2, and that means my resistance is 1 ohm. Clear as day. Now let us look at what happens when the switch is closed. So when the switch is closed, right, let's just close the switch over here. Switch is closed. There we go. Now what has happened? Now that the switch is closed, I have a parallel circuit. You can see I have a parallel circuit because now all of a sudden there is a branch in my circuit. So where I would have had my current flowing through my 2 ohm resistor, it now also has a section that goes through my 1 ohm resistor. Do you see that? Now I'm going to obviously put the other one in a different color. So let's see here. Okay, there we go. There's the current that goes through my 2 ohm resistor. So you can see that it's not the total resistance. Obviously, that is the assumption now that if I have my potential difference here at 4 volts when switch S is open, that must mean that when switch S is now closed, this 4 volts over here, it has to disappear. So we're getting ahead of ourselves. Let's go and have an answer at the rest of the questions. They ask us to calculate the resistance of the parallel circuit. So when you're calculating resistance of the parallel circuit, and I hate the other formula, not that it's wrong, I hate it because so many learners don't actually understand how it is derived. And because they don't understand how it is derived, they make the mistake when there's more than 2 resistors in parallel. So I prefer to use the formula that is always true, irrespective of how many resistors you have in parallel. So this is the formula I prefer, and I would like for you to use it as well. But the other formula is not incorrect. It only works, however, for 2 resistors in parallel. So 1 over 1 ohm plus 1 over 2 ohm, and that leaves us with 3 over 2 ohm. 3 over 2. But this is a value for 1 over our resistor in parallel. So we need to invert both the left and the right hand side. So it becomes resistance in parallel is equal to 2 over 3 ohm. Right. Next one, they ask us to calculate the total resistance of the circuit. Remember that we have previously already calculated the resistance for resistor R. Okay, the resistance value does not change unless you are dealing with the rheostat. So whether you are looking at a circuit in series or you're looking at a circuit in parallel, whether you're looking at the switch open or you're looking at the switch closed, once you know the value for the resistance of a resistor, the rest is all child's play. It does not change. So calculating the total resistance, my total resistance is going to be my resistance of resistor R plus my 3 ohms plus my resistance from my parallel circuit. So this resistance from my resistance from resistor R is 1 plus 3 plus 2 over 3, and that's going to give me 4 and 2 over 3. I'm using fractions. You don't have to. You can put it in decimal, but there's nothing wrong with fractions either. Both are obviously correct. Right. Now we want to calculate the reading on voltmeter number 1, and they ask us to explain. We make the assumption that the resistance in the battery and the connecting wires are negligible. So this holds true for whether the switch is open or the switch is closed, meaning again that V1 has to be equal to 12 volts because EMF does not change. Right. So if you've got a 12-volt battery, it doesn't matter whether you put the 12-volt battery in one device or another, it is always going to give you 12 volts. Now they ask us to calculate the reading on ammeter number 1. So remember, you know your total resistance is 4 and 2 over 3 ohms. You know your total potential difference is 12 volts. And A1, ammeter number 1, that is your total current in your circuit, because anything that is right next to your battery is current value, ammeter next to your battery, is always going to be your total current. So that's what we're trying to find. Ohm's law, R is equal to V over I, which means that you have 4 and 2 over 3, 12 and I. And when we stick that into our calculator, and here you can do it as a fraction, but you can leave it as a decimal, the current that we get is 2.57 ampere. Easy peasy lemon squeezy. The last one is to calculate the reading on V2. So remember, we have our resistance, which is 3 ohms. Our ammeter reading now, however, is different because this resistor is in series. We calculated the series resistance to be 2.57 ampere, which means that the value that we have here, this value is null and void because that is the value for a series circuit. If you are following yellow only when switch S is open. When switch S is closed, we are now dealing with a different current value. Current will change. And so the new value here is going to be 2.57. So when I am doing my substitution in order for me to calculate my potential difference, it is going to be R is equal to V over I. R is still going to be 3 ohms. My V is what I'm trying to calculate, but my current is 2.57 ampere. And so my potential difference has been calculated to be 7,71 volts. If you're wondering why I'm rounding off to 2 decimal places, it's just sort of general. Usually the instructions would say minimum of 2 decimal places, but you really do need to pay attention to the instructions to know how far you need to round off to. So I hope that was informative. Thank you very much.